All right, in problem 17.6, we have another Ferris wheel. These are good problems. They illustrate a lot of things we're talking about, so I thought I'd do this one as an example for the general idea for how to tackle these problems. So let's get started. So I drew the picture already to save some time. Here's our Ferris wheel. It's got a 45-foot radius. The center is 59 feet off the ground, and which means the bottom is 14 feet off the ground. I don't know if we have to use that, but it's nice to think about it. And we want to see, and I don't need to have this up here right now. We want to see, so it rotates at 3.2 RPM. So it goes 3.2 rotations a minute, which is about a little less than 20 seconds, right, for one full circle. And what we want to know is how high this person is when they're after 9 minutes. We want to know their Y position after 9 minutes, okay? So basically the Y position is Y equal Y0 plus R. Y is sine, height is sine, so sine omega t plus her starting position. And we know Y0, that's the center of the circle, which is 59. That's good. We know the radius is 45. We know the time is 9 minutes. We want to know the time after 9 minutes. We can figure out omega because it's 3.2 RPM, so we got to change that to radians. And we need to know her starting angle, and that's going to be the tricky part, right? Where does she start? So that's going to be the hard one. And that's why I had this thing drawn here. So let's say she starts right there. We don't know where she starts, but let's say she starts right there. That would be what we call theta 0. My 45-foot radius is messing me up here. That'd be theta 0. We need to know theta 0, and that's what we got to figure out from the information they gave us. And what they told us is that it takes her 16 seconds to reach the top of the wheel. Okay, so from wherever she starts, maybe she starts down here. I don't know. I just do it just to illustrate. But it takes her 16 seconds to get to the top. Okay, so in 16 seconds she gets to the top. Okay, so we got to figure out what omega is in radians per second. So omega is 3.2 revolutions per minute. So we got to change that to per seconds. And so we'll see 1 revolution, put that in the bottom to cancel that out, is the same as 2 pi radians. And 1 minute, put the minute at the top, same as 60 seconds. So I see minutes cancel, revolutions cancel, I have radians per second, what I want. So I go 3.2 times 2 times pi divided by 60. And I get 0.3351. 0.335 is good enough since 1 is small. 0.335 radians per second. All right, so in 16 seconds then, how far does she go? How many radians does she go? And we know she's going to end up at the top then. So yes, that's right, 16 seconds. So the angle she goes then, theta, is omega t. So she goes 0.335 radians per second times 16 seconds. That's how many radians she will have traveled to get to the top. So what's 0.335 times 60? 16 times 16. I get 5.361, so 5.36 is good enough. So 5.36 radians, which is a little less than a full circle, right? A full circle is 2 pi radians, which is about 6.28. So a little less than a full circle. So my picture is really bad. Really, she starts somewhere about right here and goes all the way around and ends up at the top. Okay, so let me erase this. So she starts right there and goes almost a full circle till she ends up back up here, right? That's 5.36 radians. So we need to know her starting angle. We need to know theta 0. So in this picture, theta 0 would be this angle. Okay? So what we know is this big angle here. So that's what that 5.36 is. She goes 5.36 all the way to there. So we need to know this thing here. So let's see. We have to be clever to figure that out. So all the way here is 5.36. So we can figure out that angle pretty easily because it's 2 pi it's this minus 5.36, right? It's how far from a full circle is that? So what's 6.28 minus that? That's how far from the full circle it is. So I'm going to not go 6.2. I'm going to do the number in the I'll just do regular 2 times pi, make a more exact number. 6.28318537 minus 5.36. That's 0.923. So 2 pi minus 5.36 is 0.923 radians. Okay, so in our picture, that's this angle here. How much from a full circle? A full circle, she would have got all the way to here, but she stopped short of a full circle by 0.923 radians. That's 0.923. Okay, so theta 0 then, from our picture, is just 90 degrees, which in radians, pi over 2 radians, pi over 2 plus 0.923. There's probably other ways to get that, but I don't know, that also makes sense to me. So her starting angle then is theta 0 plus 0.923. Pi over 2 plus 0.923. So where should I do that? I'll do that over here. So theta 0, her starting angle is pi over 2 radians, 90 degrees plus 0.923 radians. So what is that? Get a nice exact answer. Pi over 2. I get 2.4939. So let's say 2.494. So what did I just say? 2.494. 2.494 radians. That will be theta 0. Now we know theta 0, we know omega, and then then we're good, and then all we gotta do is plug in the numbers. So let's write out a formula now. Y is equal to, the center is at 59 feet. 59 plus R is 45. Sine omega is that 0.335. 0.335t plus theta 0 is 2.494. Everything's in radians, so we're good. Now we plug in t is, what do they want? 9 minutes, and we're careful because this is all seconds. We got to change that to seconds. So 9, okay, I can do that in my head. 9 times 60 is 540 seconds, right? So time is 540 seconds. We plug that in here. Make sure your calculator is in radian mode to do this. So you plug 540 in here, multiply by 0.335, add it to that, take the sine, and calculate in radian mode, and then multiply by 45, add 59. Oh, that's a lot to do in your calculator, right? Okay, so let me try that. So 540 times 0.335, 0.335 times 540, I get 180.9 plus this, so plus 2.494 equals 183.394. Take the sine of it, I'm in radian mode, yep. Take the sine of it, multiply it by 45, I get 41.6 whatever, plus 59, and I get 100.635. So she would be 100.635 feet off the ground. Pretty high, right? She's kind of towards the top, because the very top is 45 plus 59, which is 104. So she's somewhere up here after 9 minutes. And let's see if the book got it right. 17.6. They say 101.496. Whoa. 101.496 feet off the ground. Well, that must be a... Should I round off somewhere? Yeah, Spire is really close. So probably, it's amazing. Just a little tiny bit of round off there can make a big difference. So probably if I'd kept a few more decimal places or something, you know, we're pretty darn close, but it'd be slightly off. So yeah, that's all it takes is a few decimal places to be that much off. So try to keep as many decimal places as you can, because again, on a test, I got to figure out, did you do it right? Like now I'm wondering, did I do it right? I'm pretty sure I did it right. But it makes a difference how many decimal places you keep. So, okay, anyway, hope that makes sense. So thanks for watching. And all right, we'll talk to you later.